There are so many different types of ways to conduct research. Now, this isn't a research methods class, so I'm not going to go too in depth on any one of the techniques, but I want to at least point out some of the more common methods, as well as when we might use them. And so the two sort of overarching categories are correlational designs and experimental designs. In a nutshell, correlational research looks for links, looks for establishing relationships between two variables, while experimental designs allow us to establish cause and say that a variable causes another. We'll come back to experimental in the next lecture, but let's start off by talking about correlational research design. Now, we've just spent all this time talking about all these different types of variables. And so you're probably wondering, why do we care? How does this relate to research? So our goal is usually to investigate how those variables work together, or even if they work together. So what we're looking at is whether or not there's an association between variables. And that's exactly what we're doing in a correlational design, which examines the extent to which two variables are related. Now, correlations are measured using something called a correlation coefficient. Don't worry, we're not going to go too far into stats land. I just want you to have a basic understanding. So a correlation can vary from -1 to +1. It will range, it will fall somewhere in this space. And we can interpret the correlation based on a couple things. One is the direction. Is it positive? Is it between 0 and 1? Or is it negative between 0 and -1? This lets us understand the relationship, the direction of the relationship between the two variables. The other dimension is the strength. The closer the correlation is to +1 or to -1, the stronger the association between the two variables is. The closer it is to 0, the weaker the relationship is. So maybe we are hypothesizing a correlation or an association between two variables. Let's say, my animation got messed up. Let's say between smoking and physical fitness, we might predict that there is an association between those two variables. We think that as one variable moves, the other variable is going to move with it. Let's talk a little bit about what I mean by that. We often depict correlation data with a scatter plot. These are handy little graphs that let us see the direction of an association. So each pink dot on this scatter plot here refers to one participant's data or their relationship between X and Y. So say we're taking this dot here. If we follow the line down, this is where the participant fell on the X variable. And if we follow it over, this is where they fall on the Y variable. So the dot represents the intersection for that participant between variables X and Y. Now, this is a perfect correlation. You're never going to see data look this pretty. See that beautiful, perfect line? It never looks that nice. This is a negative correlation. We know this because the line is sloping downwards. It starts out high and it slopes downwards. A negative correlation means that two variables are going in opposite directions. So as one goes one way, the other one goes the other way. Another way to say this is that as one variable increases, the other one decreases. Let's go back to that example between cigarette smoking and fitness. We would expect that the more cigarettes you smoke a day, the less healthy you're going to be. We can also flip that around and say the less cigarettes you smoke a day, the more healthy you're going to be. It doesn't matter. All that matters is that the two variables are moving in opposite directions. As one increases, the other one decreases. In a positive correlation, as the value of one variable changes, the other one goes in the same direction. So as one variable increases, the other one's going to increase as well. As one variable decreases, the other one's going to decrease as well. Take the association between education and income. We would expect these to be positively associated. As education level increases, we would expect your income to increase as well. We could also flip that around and say, as the less education you have, the less income we would expect you to have. That makes sense. We would expect the two of those to go together. And we can tell it's positive, once again, by looking at the scatter plot. They are both going up. Now, you may be wondering what happens if the data points have absolutely nothing to do with each other. Your data is going to look something like this. Okay? Take the association between shoe size and exam scores. Intuitively, I wouldn't really expect the two of those to fit together. One shouldn't have any relationship or any bearing on the other one. Why on earth would your shoe size impact your exam score? And so it's exactly what this scatter plot is telling us. These dots are all over the place. See how these form a line, right? When we plot our data, we're trying to put a line through the majority of the points. We wouldn't be able to do that here. Our line would just go straight across the middle. That flat line tells us there's no correlation. Let's take a look at a few more scatter plots. And so starting with the one on the left, we're seeing a plot that represents how the number of beers consumed correlates with exam scores on a psychology test. Now remember, each pink dot on this scatter plot is referring to one participant's data or one participant's relationship between beer consumption and exam score. So take this dot right here highlighted in red. The vertical axis is referring to their psychology score. So if we follow this line over, we see they got about a 92 on the exam. The horizontal axis refers to the number of beers they drank. This person drank 2 beers and still got a 92 on the exam. Not bad, right? But take this dot highlighted in green. What did they get on their exam? Came up with 70, you'd be correct. They drank 4 beers and still got a 70 on their exam. Noticing a pattern? If you're noticing that the more beers you drink, the worse you do on the exam, you are seeing a negative correlation. We also know that this is negative because the line is sloping downwards. So you can see these data look more like what we see in the wild. The example from the first slide is we never see that perfect of a line. It looks usually more like this, kind of a little bit more all over the place. And so what we do is we plot a line that runs through the middle of all of the points. Okay. And so this line is sloping downwards in a negative direction. This tells us that the more beers people drank, the worse they performed on their exams. We could also flip that around and say the better people performed on their exams, the fewer beers they needed to drink. Okay. Since this is correlational data, we end up with a chicken or the egg scenario. We don't know if beer drinking leads to exam scores. So maybe it's something about drinking that beer and consuming that alcohol makes you perform worse on your exam. That makes sense to me. But we could also flip it around. Maybe it's that people who do poorly on the exam are drinking more beer as a coping mechanism. We don't know. That's that kind of chicken and the egg thing with correlation. We don't know which variable comes first. We'll come back to that when we get to experimental design in a little bit. Now, this is not a perfect correlation of -1. If it were, all of the points would fall directly on the line. But here we see some outliers or some points that fall away from the line. For example, we know that the pattern is that the more beers they consume, the worse they do on the exam. But let's take a look at these 2 dots in yellow. They consumed 6 beers and still pulled off an 80 and an 82 on the exam. It's pretty darn good, right? So there's always going to be some outliers. There's always going to be some data points that don't sort of follow the trend. This is a negative correlation. It's not a perfect one. We'd say this is a sort of a moderately strong association, but there's always going to be some points that fall off the beaten path. Now we're looking at the association between exam score and shoe size. Again, we wouldn't intuitively expect there to be an association between these 2 variables. And that's exactly what we're seeing here. The line is flat. It's going straight across the graph. This tells us that there is a correlation, an R value of 0. There's no correlation between these 2 variables. The dots are all over the place. And finally, this last graph is looking at the association between your psychology exam scores and the percentage of classes that you attended. Not surprisingly, as attendance increases, so does exam scores. Hint, hint, for those of you who think you don't need to attend class. The more class you attend, the better your exam scores. We can flip that around and say the less class you attend, the worse your exam scores. Don't get confused here. It doesn't matter if the variables are both going up or both going down. All that matters is that they're moving in the same direction. As exam score increases, or as percent of classes increases, exam score increases. As percent of classes decreases, exam score decreases. They're moving in the same direction. Now, I'm sure you've all heard that correlation does not equal causation. You may not know what that means. And so basically, just because two variables are related, I think my slides are backwards here. Just because two variables are related does not necessarily mean that one causes the other. And so with correlation, all we can really do is say that these two variables go together in some capacity, but we don't necessarily know which comes first and which comes second. So let me go back here. Let's take the example of social media engagement and loneliness. So say we find a correlation between those two variables. People who engage in more social media experience more loneliness. That would be a positive correlation, right? More social media, more loneliness. Now, there's three possible explanations for this association. The first, and maybe the most obvious one, is that A causes B. Social media causes loneliness. I can buy that. I could definitely see how being on social media a lot could make you feel isolated. The second possible explanation is that B causes A, or loneliness causes social media. Yeah, so maybe people who are lonely are going to seek out social media. Maybe people who struggle with human interaction might find social media to be an easier way to connect. I could buy that too. The third possibility is that maybe there's not a direct relationship between the two. Maybe there's a third variable, an extraneous variable, variable C, which we're calling popularity. Maybe it's that something like popularity is influencing our social media engagement and our loneliness. So it's not that social media and loneliness are related. Maybe it's popularity that's driving the relationship there. Correlational analyses do not let us answer this question. All we can accurately say here is that social media engagement and loneliness are positively associated. As one increases, the other one also increases. But we do not know which one causes the other or if there's a causal relationship at all. We'll talk more about that in the next lecture. Before we move on to talking about some of the different designs, I want to talk about internal versus external validity. Validity refers to the accuracy of our findings. And so there's these two different types. They are a trade-off. They sort of balance between there's a balance between the two. That's why they're depicted on a scale here. We'll start with external validity. External validity is the extent to which we can generalize our findings to real world settings. How realistic is our study? Internal validity is how confident we are that we have control over those extraneous variables. How confident are we that the change in our dependent variable is due to our independent variable? When I worked at Rowan several years ago, before I went to graduate school, we were doing a study on alcohol intoxication. And so we did it two different ways. The first way, we brought participants into our lab. It was usually 9 a.m. They weren't allowed to eat before they came in. We would weigh them, we would pregnancy test them, we would do all sorts of things to ensure the ethics of our study. And then we would administer alcohol in a very set quantity in a very set pattern. So they had to drink a certain amount of orange juice and vodka based on their weight. It would be divided into 3 cups. They would have to drink each cup in 3 minutes. It was a very, very structured process. All this time, they're sitting alone in a cinder block room in Rowan's psychology department. Not super real world, right? Not something that you usually do. It doesn't really mimic the natural world. Low in external validity. But we had really good control over our variables. We knew exactly how much she drank, exactly how fast she drank it, what else she'd consume. We had control over everything. The other way we did this study was we went to the bar. We just went into a bar and we got consent from participants, and then we breathalyzed them and we administered the study right in the bar. Here in this scenario, we have really good internal validity. We have really good control over Sorry, I flipped it around. In the example in the bar, we have really good external validity. It's really generalizable. It's real world, it's natural, but we have very low internal validity. We have very little control over the extraneous variables. I have no idea what she drank, how fast she drank it, what else she ate, what else is in her system. I have no control over any of that. Internal validity and external validity are a trade-off. You will not find a study that's high in both. Usually you sacrifice one to get the other. You may be wondering which one is better or which one is more important. Depends on your research question. It depends on how you want to answer it. And so some of the examples, the different types of research we're going to talk about in a second, we're going to be high or low in internal and external validity. So for example, there's a lot of different ways that we can conduct correlational research. Naturalistic observation is exactly what it sounds like. It involves watching behavior in real world settings, but without manipulating the situation. Super non-invasive. You're not dipping your hands in at all. You're kind of just there, objectively observing. This is really useful for when a situation can't be contrived or can't be made up. So if I were to say to you right now, laugh genuinely. Are you laughing? Probably not. You're probably staring at your computer like your professor is crazy. If I'm doing a study looking at the role of laughter on improving your mood, I can't just bring someone into a lab and ask them to laugh or try and tell them jokes. It's not going to work. It's too fake. It's too sort of contrived or set up. What can I do instead? Probably watch them in a real world setting. When do you laugh the most? Probably with your friends. Okay, so maybe I observe people while they're hanging out with their friends and record all kinds of variables surrounding the laughter. Who you're talking to, how long they laugh, how loud they laugh, all sorts of other things. I can't manipulate that in a lab setting. Another example is if I want to observe bullying behaviors of kids playing on a playground. It's very difficult to bring kids into a lab and ask them to bully. Usually they know that they're not supposed to be engaging in those bullying behaviors, so they will behave differently if they know they're being watched. So if I want to observe these behaviors, I'm probably better off just watching them in their natural setting on a playground. Now, there's some pros and cons. One of the major advantages of naturalistic research is that it's not invasive at all. It's usually pretty easy to get through the IRB, which we'll talk about when we get to ethics in a little bit. So you don't have to jump through a lot of hoops in terms of the ethical concerns. It tends to be pretty cost effective. There's usually not much fancy equipment that's required. You can often do this with just a clipboard and a pen. It's high in external validity, the extent to which we can generalize our findings. Since we're not really impacting the environment in any way, it's pretty fair to think that our findings could be generalized across a larger population. Now, nothing is perfect. The trade-off, since we have that high external validity, we have very low internal validity. We have very low control over all of the variables that are involved. We're not manipulating anything, so it makes it difficult for us to make any sort of causal conclusions. We also have to watch out for reactivity. This is when a participant's behavior tends to change based on the presence of an observer. When I was before I went to grad school, I did a project looking at bullying behavior among kids. And so I would walk around a first grade classroom and I would take data on the bullying behavior that I saw. Now, the problem that I run into is that when kids see an adult standing near them, they tend to shape up and behave in exactly the way that they're supposed to behave. This is called reactivity. So what do you think I can do to make my data still be useful? It's a couple things. The best strategy is to make yourself blend into the classroom. And so what that means is that for the first couple weeks of my study, I wasn't actually taking data. I was just walking around. Eventually, the students learned that I wasn't going to reprimand them. I didn't speak to them at all. I completely ignored them. If they asked me questions, I would just completely ignore them, pretend I wasn't there. Eventually, when they learned that I wasn't going to reprimand them or I wasn't going to punish them in any way, they started behaving in their naturally around me. So the first couple of weeks of my data really were just me blending into the classroom. Okay, so that's how we can address reactivity. Another tool that we can use is a case study design. This involves an in-depth investigation of an individual or a small number of people that we're doing over an extended period of time. We don't see case studies all that often. Most fields of psychology assess large numbers of participants so they can get enough of what we call statistical power to run complicated analyses. But where case studies come in handy is for disorders or situations that can't be recreated. We often see case studies done in the event of very rare types of brain damage or mental illness. So it would obviously not be ethical for us to recreate scenarios of brain damage, but if we come across a person who already has damage to a certain part of their brain, we can use that to better understand the function of that particular brain region. We'll talk a lot more next week about the brain. We also often see case studies used in the field of behavior analysis to consider specific behavioral problems. One common issue is something like self-injury. So individuals who are who harm themselves, often we see like head banging or hitting their head with their hand. This is something that we don't have huge numbers of participants. It's just that one individual, but we still want to try and intervene. The thing with case studies is that they are not scenarios that we can ethically recreate. So we can't really plan for them. If you're a graduate student wanting to study a really specific brain disorder or type of brain damage, it's very difficult to do that because you kind of have to use them as they come up. A really good example of a case study, I'm not going to show this video, but you can watch it if you want to, is a young girl named Jeannie. And so Jeannie has a really tragic story, but we can learn a lot from her about what it means to for human development under conditions of severe deprivation. So Jeannie was a young girl. She lived in a setting of severe maltreatment. She was kept chained to a potty seat for the first several years of her life. She did not develop motor skills the way children typically do, or verbal skills, or communication skills, or social skills, because she was just left locked in a room. Now, obviously, this is not a scenario that we could ethically recreate, but once people found Jeannie and sort of got her out of that horrible situation, she presented a really valuable opportunity for us to learn what happens when children don't have socialization in their formative years. So I encourage you to check out this video. It's a little tough to watch. There's also some dated language. They do use the word retarded, which is is not language that we use anymore, but it's language of the time. So just be mindful of the language in this video. One advantage of case study designs is that they can provide what's called existence proofs, or a demonstration that a given psychological phenomenon can occur. Take the example that all you need in the case of an existence proof is one clear-cut example. So maybe I say something like, all zebras have stripes. All you have to do to show that I'm wrong is find one zebra that doesn't have a stripe. Okay. Case studies can provide that existence proof. They also let us study those unusual or rare phenomenon. On the downside, they are typically anecdotal, so they're based on one story. Remember, we talked in the first week about how that's problematic. So they're very small scale, case-by-case conclusions. They're really not generalizable. They are low in both internal and external validity. We can't generalize our findings outside of the study, nor can we infer causation. They're also highly subjective. Case studies tend to focus selectively on information that fits our expectations, usually reflecting a particular theoretical model or slant. And as I mentioned, you don't plan a case study. It kind of just happens, like in the case of Jeannie, or you have to work really hard to seek out a specific case of someone with a specific disorder or behavioral issue that you're looking to study. Surveys are perhaps the most common tool used in research. You'll also hear them called questionnaires. It's the same idea. These are used to gather information about specific aspects of participants' backgrounds, attitudes, beliefs, or behaviors. And so what I have posted here is a sample measure of depression. So it's a series of questions. People will go through and rate each question on what's called a Likert scale, this ranging 1 to 5, never always, that's a Likert scale. And so people would go through and for each question, they would rate how often they had those feelings in the past 7 days. They'd circle a number. Now, surveys can be done in a variety of ways. The most common is self-reported, where we ask participants about themselves. Sometimes we can ask them about other people. If we're doing a study on young children, oftentimes parents or teachers would complete them on behalf of the child. Surveys are really useful. They're super easy to administer. They're low invasive. They're low cost. This is why it's one of the most commonly used strategies in research. I can put together a survey and blast it out to thousands of people at once online. Super, super easy. And so that's by far the greatest advantage of survey research. They're easy to administer. They're non-invasive. But also, the person who's doing the reporting can provide subtle information about their emotional states that others may not know. If I'm interested in someone's distress or loneliness, I can observe that to an extent, but asking them to report how they feel really gives us the most comprehensive information. They're also great for collecting lots of data really fast. The flip side is something that we call social desirability. Respondents may not either have the insight to report accurately or may choose not to in an effort to make themselves sound better. Now, I'm not trying to say that participants purposely lie. That doesn't happen terribly often, but particularly when we're studying something non-desirable like bullying or sexual assault perpetration, people don't like to admit that they did these things. So they'll often downplay undesirable behavior. So the problem with survey data is that you do have to question a little bit, how accurate is it going to be? Finally, we have something called sampling bias. Think about your course evaluations that you get at the end of the semester. These are a form of survey research. If you absolutely hated a class, you hated the professor, everything about it was a horrible experience for you, you're probably going to be very likely to fill out that evaluation because you feel very strongly. But on the flip side, if you loved the professor, you loved the class, it was a really great experience for you, you're probably also going to be pretty likely to fill out that survey, again, because you had a very strong opinion. It's all those people in the middle who kind of, meh, it was fine. I didn't love it. I didn't hate it. They are the ones who tend to not fill out the survey. So we see something called sampling bias, where we tend to get the two extreme ends of the spectrum and not a lot of information from the middle. Now, just very quickly, there are some advantages and disadvantages to correlational research more broadly. The pros are that they give researchers a way to explore questions that we may not have been able to access with experimental procedures. Sometimes it is impossible or unethical to manipulate variables or manipulate scenarios. Take sexual assault, for example. This is something that I have encountered in my research. If I'm interested in studying victims of sexual assault, I can't very well divide my participants into two groups and say to one group, you're getting assaulted, the other group isn't. Obviously, that's highly unethical. So correlational designs let us ask some research questions that we wouldn't be able to assess experimentally. It also lets us look at things in broader ways. On the flip side, correlation does not equal causation. Another common issue we see here is something called an illusory correlation, or the perception of an association where none actually exists. For those of you who did the myth and fact, the true false activity from last week, which I hope you did, one of the questions was, is there an association between the full moon and people acting in bizarre ways? A lot of people will say that that's true. When I used to work in the classrooms with children with autism, a lot of the aides would say, oh, the kids are acting up this week. There must be a full moon. It doesn't really make sense. But people believe that. So you'll hear people talk about how the full moon does weird things to human behavior. We see police stations even staffing more officers on nights with the full moon because they're anticipating more crimes. But people have actually studied this. They call it the lunar lunacy effect. And they've actually found almost a zero correlation between the full moon and any of these bizarre happenings. So the gist here is that we can run into these illusory or sort of fake correlations where people think that things are correlated, but they aren't actually. And so that wraps up our conversation on correlational designs. In the next lecture, we're going to dig into really the only way to determine whether or not we have cause, and those are experimental designs. So we'll talk more then.